Welcome to our 2023 KITE case study of HCI in practice video presentation. In this video, we present our paper on Wizard of Oz prototyping for spatial augmented reality in HCI education. My name is Danica Mast and my co-authors are Antti, Jylha and Alex Roidl. Wizard of Oz prototyping is a method that allows evaluation of interactive systems before fully implementing their autonomous elements. It is a powerful and useful experience prototyping method for exploring interface design ideas at an early stage in the design process. In a Wizard of Oz prototype, the interactivity in the system is unknowingly to the user, controlled by a hidden human operator, the wizard, instead of a fully functioning technological backend. This gives the user the illusion that the system works autonomously. Wizard of Oz prototypes allow designers, developers, and researchers to quickly develop and test interface ideas in the early stages of designing interactive systems, without having to invest a lot of time and money building a fully working interactive prototype. Furthermore, it allows testing of technology that is not yet available but might be in the near future. Wizard of Oz prototyping is not new. The technique emerged in the context of HCI around 1975 as experimenter in the loop technique. The term Wizard of Oz was first used around 1980 and comes from the movie where a giant talking head is operated behind the curtains by a wizard. Within HCI education, Wizard of Oz prototyping is part of many HCI-related curricula. However, a review of course syllabi shows that Wizard of Oz prototyping is taught merely as a possible method, but rarely required as a method for course assignments, letting students explore the prototyping technique hands-on. In this video, we present our findings that emerge from Wizard of Oz prototyping workshops as part of an undergrad bachelor program on user experience design. In the UX program, we aim at educating UX designers who have the skills and tools to design digital products that go beyond screen-based interactions. Therefore, during the course module Building Engaging Prototypes, we teach the Wizard of Oz prototyping approach to our first-year students, besides other prototyping techniques. The purpose of these workshops is both to familiarize the students with Wizard of Oz as a rapid, low-complexity prototyping method and to facilitate them in designing for interactive systems beyond typical graphical user interfaces. The contribution we make with our paper is to present a valuable and efficient way to teach Wizard of Oz prototyping hands-on, and to provide insights on using Wizard of Oz prototyping for developing spatial augmented reality interfaces in an educational setting. In our workshops, students work on an assignment where they are required to develop and test Wizard of Oz prototypes for an interactive spatial augmented reality application. Spatial augmented reality is the overlapping of a real-world environment with virtual projected content, resulting in immersive experiences. The emphasis of the assignment differs slightly each year and relates to current research goals of the research group Healthy Lifestyle in a Supporting Environment at The Hague University. For example, the assignment in 2018 was to create a Wizard of Oz prototype to support practicing of balancing skills using floor projections. The Wizard of Oz prototyping assignment covers 2 weeks. Students start in week 1 with a lecture about the prototyping method and introduction of the assignment. Their first workshop follows in that same week where they start creating their prototypes. We created a step-by-step walkthrough to help them go through this process easily. In the workshop in week 2, students test their prototypes with fellow students. We developed a workflow that supports efficient Wizard of Oz prototyping. Students can create the content of their prototype in almost any kind of content creation software, such as PowerPoint, processing, or JavaScript. Basically anything that can be controlled by a mouse or keyboard and gives visual output can work to create content. This also lowers the barrier for first-year students that might not have very advanced technical skills yet to apply Wizard of Oz prototyping. Application output that is controlled by the wizard is then sent through software for screen sharing to an application for projection mapping. This makes it possible to project on any shape or surface without distortions. In our course, we often use Siphon for screen sharing and MadMapper as projection mapping software. Over the course of 6 years, in total 93 projects have been created on the course. This provides us with insights into our approach and the usefulness of Wizard of Oz prototyping for spatial augmented reality in general. We reviewed the prototypes that were created in the workshops based on input, play characteristics, and projection surfaces. The first category is purpose. A review of the prototypes created reveals 4 main categories in terms of the purpose of the interface: entertainment, or games, physical exercise, artistic expression, and task performance. On occasion, these categories overlap. For example, when students have designed a game-like interface for physical exercise. Students have explored a broad variety of input types. Most installations were designed around movement and motions as the primary input. For example, stepping on or touching the floor, tapping or touching a projected object, various gestures, and using full body movement. This resonates with the input methods for fully functional spatial augmented reality systems. The next category is play characteristics. Most prototypes were single-player interfaces. Some were specifically for 2 players, others allowed for multiple simultaneous players. For the wizard, tracking just one user was often easiest. But if the task of the wizard was simple, such as only needing to indicate faulty movements, multiplayer setups were controllable as well. Most prototypes were designed to be competitive, where players had to reach a goal or beat a previous player. Others were cooperative, where players had to help each other in reaching a goal. We also looked at the variety of projection surfaces that were used. The constraint of the projection surface was used creatively by students by choosing different sizes, angles, and contexts for their interactions. Varying per edition of the course, the students applied floors, walls, and even ceilings as projection surfaces. In some cases, the projection was even mapped onto smaller objects. Teaching these workshops for over 6 years and reviewing the many prototypes that were developed gave us many insights. The workflow we designed turns out to be very effective. Students are able to create Wizard of Oz prototypes for spatial augmented reality interfaces in just 2 weeks in 2 workshops. Even students with still limited technical skills. Wizard of Oz prototyping in this context is powerful in providing insight in how users might use a system very early in the design process. This triggers imagination for the students to test novel and less conventional interfaces. The method allows to test realistic interaction. But the limitations of the wizard input influence the types of interactivity being explored. For example, interaction of one object because the limitations of possible manipulation by the wizard. In the future, more attention would be needed for increased input opportunities to make the prototypes more realistic. The method also has some other limitations. The workflow of the Wizard of Oz for spatial augmented reality with projection mapping seems to guide students towards certain kinds of interfaces. And also in certain floor and wall prototypes, occlusion can hamper the experience of the people interacting with a prototype. We see that students apply this method in future projects, making a lasting impact on them. Students make use of the projects in their later study years and some in their jobs after graduation. Overall, our approach shows a valuable and effective way to teach Wizard of Oz prototyping for spatial augmented reality interfaces in human-computer interaction education. Thanks for viewing our video presentation for CHI 2023. If you would like to know more about our work, please read our paper or feel free to reach out.